Hi guys, right, we're back again with some more of the auction test equipment. We have the TTI digital multimeter here, also known as the RS Components Limited digital multimeter. So if you've not watched the frequency counter video, then pop up there or up there or up there or down there or wherever it pops up, and watch that, because this is probably going to be more of the same. Again, this is an auction recovery. This is part of a series of instruments that Thirlby Thamber are made primarily aimed at institutions and fairly low end stuff. They're not particularly high end bits of equipment, they're cheap but they do the job. I trained using this kind of equipment, and there are plenty of videos on the other members of the family around. This one doesn't feel like it's got a battery in it, so that's a good start already. With the other one we had the very decayed batteries in there, and we have an empty battery compartment, so that's a good start. Now, unlike the other one, we have no DC jack on this one. As you can see, there is space for it, but it's not fitted. So hopefully with this one, all we're going to need to do is give it a quick spritz of contact cleaner and get some batteries in it. There are... well, that's not a good start. There's no screw in there. There's no screw in there. Don't think there's a screw in there. There is a screw in there. So we're going to have to go and find some machine screws to go in here. Let me grab my magnetizer. That one is very, very cross-threaded, but it's quite a long screw, so I don't know if I've got anything to replace that with. Is that all we had? It was. Now the last one, everything was in the base, so I think we'll go for the same in here. Right, we've got a lot more in here than I perhaps expected. So we have a TSC, who are TSC? TSC 7106 RCPL. That looks slightly Cyrillic, that font as well. That's probably not a good thing at this time and date. And we have, unfortunately, lots of green fuzz down there on that. So that's not a good start. Let's get the bail out of the way. Let's get that out of the way. This looks like it is a shield and safety plate. We've also got our fuses under there. Now this is quite an elderly machine. I didn't find a date on that other one. 83, 83. Can't see anything on that chip. Not actually that many chips in here. 83. So yeah, I think we're talking 1983 here, and you can see all of our range switches are wired through up there. We have our shunts in here. We have some Selectron test resistors in here. But yeah, it doesn't look like there's a great deal to this. It looks like we have some battery regulation down there. So I guess our first thing is we're going to take this out, because we're going to go the same route that we did with the frequency counter, which is put lithium ions in. And we'll get this out of the way for now. I might actually go to the extent of reusing those. I've just brought everything back upstairs after doing the job. So I think, just to keep this sane and avoid having to take the board out completely, we may well reuse these wires. I'm not mad keen on the idea. And we've got two screws here that come out of the battery pack, which we might be able to use to replace these ones. Right, let's get... there's our measurement hybrid there as well. Cadec Electronics Limited, never heard of them. Let's just get into the back of these switches. power switch there, that's good. Right, I think before we go too much further down this rabbit hole, let's make sure that we actually work. Now the frequency counter got enough out of one lithium ion to work. Can we do the same here? No, we cannot. These lithium ions are all charged. Oh no. So yeah, it's only a 3.5 digit, so it's not going to set the world alight. But everything feels okay. And we'll turn that back on. I think what I'll do is, because we're going to go the same route, we'll stick these together first. I wonder if I can actually get in. I don't know how well it shows. Let's zoom me down a bit. I wonder if I can actually get in on those terminals. We'll try to get some solder on there in a minute, but let's get this pack put together. I need a drink of water because I've been talking for a while. Curiously enough, given that these are a number of videos being shot back to back, so I know that I've just had to talk with you about solder, and we've just had a customer come in and ask for a battery to be soldered, which he was struggling with, and he goes, oh, is there a trick to it, what do I need? And going back to what I said about beginner soldering and the other one, try and create some space. So we've got, for doing batteries, we've got Weller leaded solder there, 1.5mm, lots of flux, a good iron. I've got a Weller WTCP. A lot of people will try and use this stuff, which is the stuff that is peddled en masse on Amazon and places like that. It's garbage. I mean, my iron has a lot of thermal mass. It is a proper temperature controlled iron. It can just about cope with it, but if anything in the process is not quite right, then it really starts to fall down a bit. Right, we have hot snot. So what I did on the other one is I went down the middle, round there and down there. The idea is to not quite sure what happened there. The Lumix software has updated and it's done a couple of weird things, so sorry if that jumped all of a sudden and you missed a bit of something. So we now need to connect these two together. So we'll do it exactly the same way as we did on the other one. Soldering iron is warming up over there. Now I could spot weld these. I have the equipment and we could make a proper lithium battery pack up. The biggest problem with doing that is that two cell chargers are slightly less common and a little bit more difficult to set up, so we'd need a charger and a combined charger and protection board. With modern electronics there is eminently enough room to put a mains power supply in here and a charger and a protection board and make this quite safely mains powered without compromising it. However, it's not really worth the grief. This meter is destined for a colleague who is not particularly familiar with electronics. He will get the same warning about not killing the batteries. So this multimeter is destined for a colleague who does not know a great deal about electronics. He will get the warning about the batteries, and it's a start for him to start getting used to how a multimeter works before we give him a really nice bench meter to blow up. Our soldering iron is now hot. It sounded awfully like I was going to launch something else off the bench there. A little bar of solder on there. Trim that down to a sensible length. Incidentally, for stuff where you're not hugely worried about quality, or where, let's face it, something like heat strip, where for this kind of stuff quality is not going to be the be all and end all, these little boxes of things you can get from places like AliExpress and Amazon, that's quite useful. I mean, that was a box of these battery holders, it's now an empty box, and to be fair, a nice clip seal box like that, that's actually fairly useful anyway. That will get something put into it and that will go in with my tools. I've covered one of your microphones up. There you go, that's better. So let's just shrink that down. And I've already turned the hot snot gun off, so that's not tremendously helpful. And we'll just quickly put a little bit of a twist in those. I can also see from the angle the light is reflecting off of the board that this has been conformal coated as well. So that's good. Right, what I'm first going to try and do, because I don't want to take this out if I don't have to, is just try and see if I can get the solder to wet the crimp terminals. So these are the quite commonly used crimp terminals, where you crimp the wire in and then solder the crimp to the board. And yes, that's wetted quite nicely, so we'll get rid of those. So yeah, this is what I mean about the solid wire. I mean, if we take a bit of that, just a little experiment, as you can see, it's not quite easy to get it. So yeah, you can see that one's quite rigid, doesn't really want to move, that pops back, but I can bend that into all sorts of shapes, and this one will pop back. It's only cheap Chinesium wire, but the biggest problem with this stuff is once you've flexed it a few times, as anyone will know, it's not going to do it now, is it? There we go, I can feel it's just gone, and you end up with this situation. So it's not immediately obvious that that wire is now broken. You can see by the way it moves at this point that it is, and if I put pressure on it, it will just snap. Something like this, it's not such a problem, but if you start using this stuff in automotive situations, and I've seen people wiring stuff up with Cat 5 stuff in vehicles, you'll get snap cables, and that will be the end of whatever it is you're trying to do. So let's just get those wet. Our battery terminals should already be, but we'll battery wire should already be, but we'll add a bit more. We don't want to add absolutely tons on here. I think we are going to have to fire the hot snot gun up. So that's our battery negative on that one. And our battery positive on there. There we go. Right, switch back to the hot snot gun. What it is I'm quite restrained on sockets over here at the moment, because I've plugged everything in off to one side rather than using the lovely new sockets I put in there. Right, let's grab our FEM. I think we want that to sit in there. So this is where the pick and pluck stuff comes really into its own. So we want, I reckon, that there, and that there, and that there. That should do us, I think. So what will happen, we put the lid on, I'm not going to glue it, that will crush down, and that will do the job nicely for us. Hot snot gun needs to be turned on. Let's chuck some batteries on and have a quick run through everything. Again, these are fully charged, and you just watch me very nearly do what I was saying to be careful of. So you've got a ridge around the top of the battery there which identifies positive, but you can put them in either way and they will work. That would probably have been a lithium battery fire. So bear with me, I can actually test this, can't I? Bear with me. So another job we are going to have to do with this before it goes out to where it's going is this is using uninsulated 4mm plugs. So if I reach over here and pull one out of my other meter, so this is what this one uses, and this is an insulated or shrouded 4mm, which is no good. You can buy them in the same form factor as those, so upgrading this is not a problem. So what are we going to go with? That's our DC input. It's a nice positive. And you can get, you can get these test leads like this still. It's not a problem. These are brand new. The issue is if you imagine them sat in like that, with this being the socket, there's a lot of scope for you to touch something you shouldn't. Right, let's go for some volts. We're on DC, which means we want to be up. 20 volt range should do this. I'm pretty sure this battery is charged. So that says 4.09. Bear with me. And my own meter is on ohms, which is not helpful. Now that meter, which I trust, is on 4.09 as well. So there we go. This has been calibrated. Well, I think there is a date on that cowl seal. So we'll have a look at that in a sec. Let's just turn off again. Oh, they're a bit stiff. Northern calibration. There is no date on here. There was some more stuff on the top, so we'll have a look. Right, hot snot gun's charged, so we're just going to go squidge on those battery terminals. That's all I wanted it for, I think, wasn't it? Oh no, we were going to do that as well. Just posh that down there. It's literally just to keep it out of the way. I can see that 4070 is slightly out of its socket. Have I got some isopropyl over here? Yes. So I'm not sure what's actually growing on that plastic down there. I don't think it's corrosion, because I don't see any sign that the battery has leaked. That's conformal coat. I'm not overly worried about that. We'll just quickly zap it with that. Right, so we've got, should we put the big one in at this end actually, because it makes it a bit more easy to grab. One there, one there. Oh, don't want that to happen. Didn't quite wait long enough. One there. We need to put that back on. That fuse is obviously good. Just pop our shield back in position. Level of screws for that. I have no idea what that was. Oh, it was me knocking something against the microphone. So where are our screws? There's one there. So I have also just noticed that we've only got a fuse for the 2 amp range. This has a 10 amp. Well, I think it's got a 20 amp range. Right, there's those. We need our bail. Yes, I should have checked the resistance range as well. Where did the lid go? There we go. There's a silly little bit of plastic somewhere. There it is. Now you can see how high this is all sitting with this foam in. I may have to cut that down. Battery fall straight out the back. I guess that proves that we haven't trapped it in any way. Let's get that one in quickly. So as we said, we didn't have a full complement of screws, but we've got a couple of extra ones now. There we go. One in there. Where are they? There they are. One in there. So the foam is acting as a bit of a spring and pushing the case open slightly. Put the other one in the back here. I don't think that other side is pushing apart. I'll go and have a look, assuming I don't have any actually on the bench, which I do. That's him in. Actually, I have a feeling that the reason there was no screw in that corner is there's no thread left in there. So there we go, and we can nestle our battery in there quite happily. Yep. That all feels very loosey-goosey. We could really not get that one in any better than that. I say it's quite possible the reason that there were no screws in these positions is quite simply they're just completely cross-threaded. I think we can tighten that one up a bit better. There we go. That feels better. So there we go. What we didn't do is resistance. Bear with me, I will go get a decade box and we'll have a quick look at that. There we go. Right, I guess the first thing we want to do is know what our zero is like. So one in there. One in there. And we'll just short them together like that. Kilo-ohms is the best we're going to get. Looks like 200 ohms. That's possibly our lowest. No, 2 ohms is our lowest. That's good. I don't actually believe that, but that's good. Let's go into our decade box. So that is 1 ohm. 5 ohms. This is looking quite good actually. 10. Is that right? Yes. Yeah, I'm out by 1. Sorry, that's 2k. So that's ohms and k. So we're going up to 20 mega ohms here, which, to be fair, I think is more than my desk meter goes up to. So yeah, we're fairly happy with that. Let's go back to 0. So we're not quite zeroed, but I think we're in tolerance, and that is good enough for us. Right, so that was 10s. This should be hundreds. 100.5, that's not bad. It should be 500, which we're not going to get. So let's go to 2. Yeah, that's sort of right on the range. It says it goes to 200 ohms. However, it can't indicate 109 ohms, so it's 1.999 or 99999, whatever. So if we go there, 200 bang on. 600, yeah, 10, close enough. 1000, right, okay. Obviously I've got to allow for the fact that this decade box isn't properly calibrated, so we can't see 5. What do we see on 2? Okay, so we might have a bit less here. Oh no, that's all. Nope, happy with that. 0 and give it 40k. Of course we won't get that. That's good. 40k, okay, 50k, bang on. Yep, so I'm not going to carry on going through that because it's all boring, but yeah, that all seems good. So that is ready to go back into service. I'll do the same as I said I would do with the frequency counter. I'll put a warning on it saying that it has a lithium pack, treat with respect. Now, oh, that's a bit dodgy. Do we have any dates on here? Yes, we have a calibration date, and that's not bad given that we're talking about 1983. The calibration on this expired in August of 2004. So this was in use for quite a few years. I think that may also be a British Rail identity. So we've got the old style plastic embossed dymo there as well. It's had a fault repaired by the looks. But yeah, so I reckon 83. It's consistent with everything. I might take that apart and investigate what's going on there. But again, that is another one now, ready to go on the pile. That is effectively ready to play now. And that's 2 for 2 rescued so far. I don't think I'm going to be that lucky with all of it. Anyway, thanks for watching. If you like the video, subscribe and hit the bell. And as I said in the other video, help us grow the channel. Thank you for watching. Bye.